All right, welcome back, guys, to part 2 of 5C. So, as you recall, we had just finished creating this frequency table, okay? And remember, a frequency table really just has to include these bins or categories, however you want to refer to them, and the frequencies, okay? The frequency of the data that falls within each of these bins. These other two columns are not necessary for it to be strictly a frequency table. However, I think in your project you will need these other two columns here as well, okay? But anyway, so now what we're going to do is look at some visual ways to organize and display data, okay? And so we're going to start talking about bar charts and pie charts. So a bar chart shows each category with a bar whose length, or height rather, corresponds to the frequency or relative frequency of the data in that particular category. Okay, so like, you know, if the categories were different colors and we were asking people what their favorite color was, and if blue was the most popular color, then it would have the bar that corresponds to that category blue would be the highest, okay? And typically you would have the vertical axis labeled, and it would be labeled in frequency, so like 1, 2, 3, 4, 5, etc. So if the bar that corresponds to blue has a height of 10, then that just means that 10 respondents answered blue as their favorite color. Sometimes, though, that vertical axis will be labeled using relative frequency. Okay, we're going to look at some examples here in just a minute. And then there are pie charts, which I'm sure you guys have seen both of these. Pie charts are used primarily with relative frequencies because the total pie has to represent the total frequency, or relative frequency, or 100% of the data. Okay. And then furthermore, the size of each wedge is proportional to the relative frequency of the category that it represents. And so I've got some examples down here. And so what we see both a bar chart right here, and we see a pie chart, okay? Now both of these have been constructed from the data that came from this frequency table. So this frequency table, it just has the bins or the categories, and you can see these categories are actually grades. And so these are not actual percentages like we did previously. And then over here in the second column we have these corresponding frequencies, okay? So 4A's, 7B's, 9C's, etc. So let's look at the bar chart first. So as you can see, along the horizontal axis we have these different categories, which are the different letter grades. And there's a bar that corresponds to each, and the height of that bar corresponds to the actual frequency of the data in that particular category. So because there were 4 A's, this bar that corresponds to the category A has a height of 4. And then sometimes you'll see this too. On the right side, this vertical axis here, if you want to call it that, it is given in relative frequency, okay? But anyway, you can see these bar charts are really nice, guys, because it makes it more readily apparent how the grades are distributed. So it's easy to just glance at this and say, oh, well, the tallest bar here corresponds to C, so there were more C's. And then after that, there were more B's, and then there were more A's, fewer D's, and then there were less F's, okay? And so what you have here, this is actually called a grade distribution or distribution. It shows you how the data is spread out over those different categories. So this is a great visual way to discern patterns in the data, okay? And then what we have over here is a pie chart reflecting this same information, okay? But you'll notice that the size of the wedge actually corresponds to a relative frequency. So C right here is the biggest piece of the pie, and that's because there were more C's than anything else. Now, they came up with this relative frequency by taking 9 and dividing it by the total. Okay, so just like we did in this table up here. And so, you know, if you were to divide 9 by 25, you're going to get 0.36, which as a percentage is 36%. And so you can see the next largest slice of pie corresponds to the number of B's, which account for 28% of the grades. And then you can see the smallest piece of the pie here corresponds to F, which there were only 8% of the grades or 8% of the students, whatever. Okay. All right, so now with any sort of graph or graphical representation in data, you need a title. Okay, and if you look at this one right here or this one, both of these are titled, and they're both titled grade data, and that's very fitting because that's what this is. So you're going to need a title, and if you're using a bar graph, you're going to need to label your axes. Your vertical axis, okay, should have a title, and the title here is frequency of grade. Okay, so that's straightforward enough. And the title of the horizontal axis is just grade. And then furthermore, the vertical axis is calibrated in positive integers. So it starts at 0, then goes to 1, then goes to 2, because remember, these are frequencies that we're counting. Now, of course, we wouldn't have a horizontal or vertical axis with a pie chart, right? Because a pie chart is totally different. And then sometimes you might need a legend, but I think for all practical purposes, at least in this course, you're not really going to need a legend. Okay. All right. Now, these bar graphs and these pie charts, these work great for qualitative data. Okay, and so you can think about these grades as being qualitative in a sense. An A is like for excellent, a B is like for good, a C is for average, a D is below average, and an F is for failing, I guess. Okay. But anyway, so bar charts and pie charts, they're typically used for qualitative data. Now, what if we want to display quantitative data? Okay, so similar to like what we did up here. This is quantitative data, these scores from this 100-point exam. Then we use something that's similar to a bar chart, except the bars are all pushed together so that they're touching. Okay, and that is called a histogram. And we're going to look at one here in a minute. So a histogram is a bar graph for quantitative data categories, and the bars have a natural order, and the bar widths have a specific meaning. Okay, so typically what you would do, so let's say we were using this data right here. When I start going to make my bars for a histogram, I might start down here, and I might label my horizontal axis. I would start at maybe at 70 or 71 and go to 75. So I could be 71, 72, 73, 74, etc., all the way up to 100. And so the first bar would only exist over this range on the x-axis, and it would have a height of 6. And there would be a bar right next to it. Okay. There wouldn't be a space between the bars, and it would have a height of 6 as well. And then there would be another bar, and it would have a height of 2. Okay, and we're actually going to see this evidenced below, right here. This is a bar chart, or this is a histogram of that data that we made that frequency table. And so you can see, well, I thought this came from that same data, maybe it didn't. Oh, well, it also depends on how they made their bins. So if they started at 70 and went to like 74, and then this next one started at 75, that could cause a difference, okay? But anyway, what I'm trying to point out here is that you can see these bars are touching, right? 70 to 75, and then 75 to 80, and then 80 to 85, 85 to 90, etc. And the height of each of these bars just corresponds to the frequency of the data that was in that particular bin. Okay, so that's an example of a histogram. And then a line chart shows the data value for each category as a dot. And the dots are connected with lines. So for each dot, the horizontal position is the center of the bin it represents, and the vertical position is the data value for the bin. So for example, using the same data, typically, let me kind of draw this. We had a bar right here, okay? It went up to a height of 4, and it came down. So with a line chart, you put a dot right at the center at the top of that bar. And then when you have your next bar, okay, whoops, I drew that too far to the right. Here we go. You put a dot right at the center of where that bar would be. And the same thing for these others, guys. You'd have a bar right here. Your dot would be right in the center. You'd have another dot, or you'd have another bar, and your dot would be right in the center. And then another bar, and then another bar, okay? So to come up with a line chart, you could sort of think about starting first with your histogram. Get a different color here. Let me put a point at the top of each of these bars right in the center of the width of the bin. Okay. And then when you do that, then you connect these with straight lines. And that's how you create a line chart. And that's what they've done on the right here. Okay, and then you go all the way down to 100. Or, well, they actually go over, but I'm not sure why, because the data stops at 100. But anyway, that's kind of the way it works. And let me erase these bars real quick that I drew. And by looking at this, by looking at a line chart, you can still see how the data is distributed. Okay? So you can see, like right here, there's a lot of high C's. And then over here, there's fewer lower C's. And then as we go to the right, the scores or the frequency the frequencies diminish. Okay, and so you can see there's actually fewer high A's or mid to high A's than anything else. So this line chart still has sort of the same shape as this histogram. So we still get a sense of how that data is distributed. The majority of the data is over here, kind of in the C's and maybe in the B's. Okay. And then less of the data is in the higher B's and A's. And so we get that same sense by looking at this line chart. Okay. All right. I think, guys, I may stop part 2 right here, because what we're going to do now is we've got, so if you look at this, this says Oscar-winning female actors. So the data here is basically the age at which these female actors won their first Oscar. Okay? It says the table shows the ages at the time when they won the award. An Oscar or Academy Award, it's the same thing. Through 2017. It says make a histogram and a line chart to display these data. I'm just going to do, well, I'll do both. I'm going to do a histogram, but this is the frequency table. So you can see what they've done is they've divided and they've made their bins in basically decades. Okay, so this first bin represents the 20s, then the 30s, then the 40s, then the 50s. And notice the distance between each lower bound in each consecutive bin is 10. 20, 30, 40, 50, or if you look at the upper bounds, it's 29, 39, 49, 59, etc. So all of these bins have consecutive or consistent widths, okay? And so the frequencies are over here to the right. So you can see that when these actresses are in their 20s and 30s, that's when they're most likely to win their first Oscar. And then there's not as many, but still a significant number of female Oscar-winning actors that win their first Academy Award when they're in their 40s. And then on and on, okay? You can see as you get out in your 70s and 80s, if you're a female actress and you're still acting, it's very unlikely that you're going to win that first Oscar. So, in other words, if you're getting up into your 60s and 70s and you're still acting, it's very unlikely, if you have not won an Oscar yet, that you're actually going to win one. Okay, and we'll discuss more about why that is and what kind of picture this data is actually telling us in part 3. Okay, so I think we need one more part 3 and we'll finish up this section. So I'm going to let you go for now. I think this is very interesting, guys, because we can look at, we can take a sample, we can have this data, we can organize it using the frequency table, and then we can make a histogram. We can look at that histogram and see what patterns, or see what is that data or that histogram, what story or narrative is it trying to tell me, or commentary. Okay, so that's what we'll look at in part 3.